Question 24. Suppose we're testing the hypothesis, blah, 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 blah. Which of the following is the p-value of your hypothesis test?
I put 0.091, but I don't have any work. So I don't
Okay, so that's what I originally put, but then I went back and I read it again. So our alternative hypothesis is not equal to. That means it's going to be a two-tailed test.
Mm-hmm.
And right now, the area to the right of the z-score is what's highlighted. So it's only a one-tailed test with this p-value being 0.091. So we have to double that 0.091. And if you do, it equals 0.182.
Yeah, I see that now.
Because that's what I originally had. And I was like, no, that's not right. So it's the 0.182.
Okay.
All right, question 25. Suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of the X bar is normal? I remember this question. I don't know why, but any N will do.
Yeah,
and I don't know why.
Yeah, I originally put 30, but then I noticed it says it's normal already, so any N would do because it's been determined normal.
Exactly. Woo woo! You're so great.
Hmm.
See? Look at the things we learned. Okay, 26. A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken, and the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67, and the sample of 56 women taken for the p-estimate for the true proportion of women. Are the requirements satisfied to perform this hypothesis test, and why? We're on question 26.
I got it. So will you quickly just tell me 24 and 25, and I'll work through them later?
We've broadcasting it, yeah, but it's C for 24, the 0.182, and 25 is F, any N will do.
I didn't think we had to record this one.
Well, Haley's gone, and so I'm recording it for her because nobody has any time to help her afterwards.
Okay. All right. Okay, so the requirement satisfied for this hypothesis test. So we just have to figure out if they are both equal to or greater than 10.
Correct. Hi. Oh, you're stuck.
Oh, we have to do it for both men and women.
Correct.
Okay. Equals 41 times 7. My gosh, 5 boys just make so much noise.
Yep.
Yeah.
That's not right. I did something wrong on the second one. Did I write back?
What answers did you get?
We got 27.47 on the NP minus 10.
Okay.
And then 47.04.
Yep.
And then I think I wrote down the equation wrong. N times 1 minus, I put N. It's P minus, I'm losing it, sorry. So it's the P hat, which is 0.67. Okay, sorry,
You're fine. Whoa, excuse you. Oh, so Jolene, I meant to tell you, I took a look at the PowerPoint. It looks really good.
Mhm.
But when I opened it in Google Docs, it cut off half of them.
Well, why do we need it in Google Docs?
We don't. I'm just letting you know. If that's how
Oh.
she ends up opening it,
Well, if I just send her the PowerPoint file, she won't need to open it in Google Docs at all.
well, you should be able to put it in whatever it's called. Submit it through iLearn. And it shouldn't either. It shouldn't cut it off either in iLearn.
Yeah. Okay, we do have one of them that's less than 10.
Correct. So are the requirements satisfied?
No.
No, because in at least one case, n times 1 minus the p hat is less than 10.
Yeah. Okay.
Okay.
The ding one, that's 8.96. Okay.
I know. All right, 27. A study was conducted to measure
Well,
the effectiveness of a diet. Oh, sorry, what?
So that makes sense that it's no, but it says the sample size of women is too small, so that's still a no, even though it's not too small.
I don't have.
Is that not?
Hold on.
Well, there's only one no answer here.
I know.
So it says no because in at
Okay.
least one case, the n
Yeah.
times the 1 minus the p hat is less than 10.
Yeah, I get that, but
Oh, because the sample size for the women is too small. But yes, that's the same. It's the same.
it's annoying because it's not the same words.
Yes,
At
I
all.
agree. I agree. But because the sample size is so small, it's not giving us enough. That's why it's the
Yeah.
same.
A little bit, okay?
Does that work?
Yep.
Okay.
Oh my gosh, my one nephew is locking him in closets, and I say, let him out there. And then Wesley, who's like 9, comes walking out with a motorcycle helmet on. I'm like, what in the world? Okay,
It's
sorry.
spring break. All right, 27. The study wants to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis?
Well, if it's before and after, and they're not comparing each other, but they're comparing a difference. So it's going to be the UD, because it's a paired sample, is not equal to 0.
They're
Are they two
comparing
separate?
weights.
Is it 1 and 2?
No, you're right, but they're comparing weights, so it's not a quantitative.
Oh,
It's
okay. So it's just mu is not equal to 0.
No,
What?
because
Sorry,
that's
obviously read the question.
we're looking for the alternative hypothesis. So we're dealing with categorical here because we're looking at weight. They want to know if the weight before is the same as the after scores.
So it's our P1
Right,
is not equal to P2.
right.
Got it.
Even though weight can be added to, they're dealing with the diet of the weight. And is the diet what's changed? Is that
So we're dealing with our P.
so we're dealing with the diet, so we're dealing with categorical here.
Okay.
Okay. Do you agree, Andy?
That's what I had.
Perfect. 28, Weight Watchers wanted to predict how much weight a client could lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into 2 groups. One group dieted but didn't exercise. The other group dieted and followed the exercise program. For the exercise group, they used linear regression with percent compliance with their exercise program as the explanatory variable and pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean?
I gotta remember what the residual stands for.
So the residual is the difference between y and x. Hold on, let me get to it. I have it written down.
Okay.
The residual for an observation is defined as the difference between the observed value
Okay.
of y and the value that would have been predicted by the regression line.
Okay.
So
So,
the explanatory variable is our y,
okay.
correct?
Yeah. Predicted weight loss was
Is that right, Andy?
I don't know. I think it's either A or D.
yeah, so we're dealing with the predicted, right? Because we don't know the actual yet.
No, we're dealing with this. Okay, so okay, so the actual is the y. And his actual weight is our difference between the x, which is our predicted weight.
Okay.
That's not right. That can't be right because our y is always the predicted.
Yeah, because y is what we're trying to compare. Yeah.
So why do I have this backwards? The residual for an observation is defined as the difference between the observed value of y, which is our predicted, and the value that would have been predicted. Okay, so when we go to lesson 23, and that very last answer, it's saying a scatter plot is made to test the correlation between two variables. When residuals were calculated, one residual had a value of 4.5. What does this mean? And the answer is that the actual y value was 4.5 units higher than the predicted y value. So I think the answer is his actual weight loss was 5.5 pounds higher than his predicted weight loss. That's what I think the answer is based off of the answer to our homework in 23, lesson 23. That's all I've got. I don't know how else to explain that one.
Okay. Well, Andy, unless you have I'm okay with that unless you have something different.
I was just guessing. Which one did you say?
What?
His actual weight loss was 5.5 pounds higher
So you
than
don't
what?
Predicted.
Than predicted.
And I'm only going with that one because of how it's worded in the answer for number 31 in our lesson 23 homework.
Okay.
Because remember, the equation here is y minus the y hat equals the y minus the b0 plus b1x.
Okay. And then just go when you're done.
Because it is the predicted weight loss.
After you, okay?
And the residual is the difference between the two, between the weight and the predicted.
I'm just going to go with you for now because it makes sense, but I don't know how it makes sense.
I'm just going off of the answer from lesson 23. Okay, for the study in the previous question, and then I got to get on my papers. The B1 of the regression line was 5 pounds. Interpret this statistic.
I think it's C.
I think it is too. As the percent compliance goes up by 1%, the average weight loss in 3 months increases by 5 pounds. That's what I think it is also.
Based off of previous questions also.
Yes. Okay, when creating a scatter plot, a residual...
The percentage compliance goes up by 1%. On average, 5 pounds are lost in 3 months?
Uh-huh.
Okay. All right.
30. When creating a scatter plot, a residual plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? Check all that apply.
All right. I know that was in the last lesson. Okay, so there's a linear relationship between X and Y.
Yes.
The error term is normally distributed.
Yes.
Variance of the error consists of constant for all values of X. The X is, sorry, it feels like my house is going to fall down. The X's are fixed and measured without error. The observations are independent. So now that I read those, and I've got to go back and check all of those. Okay. So it's all of them except the residuals are normally distributed.
No, that one's right.
That one's right also. So it's all 5 of them.
No.
No, which one am I missing?
The X values are measured without error. You can't test that. according
Okay.
to-
Nor can we test that the observations are independent.
Yeah.
So it's the, okay.
So
So
it's the
it's,
second one and fourth and fifth one.
okay, got it.
And this question is more clear than the other one we had because it actually says when creating those
Yeah.
plots. The last one didn't say that.
Correct.
Yeah.
Agreed. Okay,
Okay.
so we've already talked about this one. This is my for question 33. So we've already read through this. So compute the sample correlation coefficient to the price of the tickets 14 days before compared with the price of 90 days, ticket days, blah, 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 blah. So what we're trying to figure out here, we want to predict the price for 14 days out. So that's our Y, correct?
Yeah. Wait. Yeah. Because I
Where
had
are-
it backwards, so you guys are right.
So our 90 days is the actual, and we're trying to predict 14 days, which is our Y.
Mm-hmm.
So when we put that in, what's the correlation coefficient?
It should be 0.780
Yes, that's what I have.
because that didn't change.
Correct.
And it should be linear with a fairly strong positive.
0.780, sorry.
0.780.
0.780. And
I agree with you, Andy. It
linear
should
with
be
a fairly strong
positive association.
positive
Yes.
association. Okay.
Oh, see, this one's not even the same question.
Mm-hmm. Well, it kind of is. It's just it's asking you the value, the variables.
Oh, I see what they're telling me to do. Okay, I know what I need to do for this question. I know what I need to do. So my Y equals plus 0.627x. I see what it's asking me now. I don't know why they didn't just ask us like this.
So you were going off of just the homework, which we're finding is not all the full information.
Well, it was very unclear. Fill in the missing variables for the linear equation, which I know what the difference is, by the way. So, Andy, you were right with the right equation that you were using.
So our y-intercept is the 90 days, is the 14 days.
Correct.
Our x is the 90 days.
Yes.
Okay.
So they wanted the estimated linear regression equation, which is the lowercase b. Well, the true linear regression equation is the beta naught with the capital B. That's the difference. That's one of the differences.
Yeah.
Plus the epsilon, and we're dealing with a prediction of the p hat, or the, I'm sorry, with the y hat. Those are the three differences.
Okay.
So what's the y-intercept?
I have
that.
115.640.
115.640, yeah. And then the slope is 0.627.
Agreed. All right, I wasn't sure about this one, but I think I did it correctly.
Don't you just put 200 into that space in the Excel?
That's what I did.
And x,
Yeah, that's what I did.
so the predicted is 240.7 or 9 point or 241.0.
0.0.
Can you say
That's-
that again?
241.0. I think when I did this on the homework, I did it wrong and I was really annoyed. Because I thought, yeah, completely something else. Anyway, sorry.
Okay, so for the
We have almost only 10 left.
say for the next 3 questions, construct a 95% confidence interval for the slope of the regression line obtained with 90 days before flight ticket prices are used to predict the 14 days before flight tickets. So what is the lower bound of your confidence interval?
5.518.
That's what I have.
Yeah.
518.
Yeah.
The upper bound.
0.735. Whoops. Got fingers. Okay.
And so our margin of error, of course, the one thing that wasn't on our, this question's not on our.
I will never forget this because of.
I know.
Yeah.
Me neither. So the margin of error is 0.1085. Is it rounding to 3? So
I would go 108.
I have 85, so it should be 0.109.
No. I'm sure either one will be fine, but in Excel, because of all the rounding, I have 0.10824. But I think, remember Andy and the homework did the other one, and it was fine.
Okay.
So I'm going with 0.108, but you can do.
Yeah, I'll do 0.109.
For the next 4 questions, conduct a hypothesis test to determine if the slope of the true linear regression line is not equal to 0.
Oh.
What? Oh, true linear. Okay. Sorry. I was doing it right. Okay.
So uppercase?
So the capital, yes.
Yeah.
Yeah. So I put D.
That's what I have also.
Yeah, because we with the slope, right? When we're doing.
Yes.
Yeah, which is the 1. Okay.
So what is the value of the test statistic?
I have 11.510.
That's what I have also. Your p-value?
0.000.
Sweet.
Oh, yeah, that's what I had.
So what is your decision?
It's low, so we reject the null.
So we're rejecting because there's sufficient evidence. So the third one down.
Yeah.
Guys, I totally have that one backwards. I'm so tired and messed up. I was just like, ooh. I never get these ones wrong, but apparently I do. Reject the null. There's sufficient evidence. Yes. Yes. In the United States, mothers. Okay. I think I have all of these correct, but I'm not going to say anything.
Because we're so good at all of these.
Okay. So in the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the program and birth weight data in record. Sorry, data is recorded. Which hypothesis test would be most appropriate for this study?
Well, you're only looking at the birth rate of 30 mothers. So you're not comparing data, right?
I agree.
And it's categorical. No, it's not. It's quantitative. So that it's got to be one sample, or it's a one sample or it's independent. No, it's one sample. T-test.
That's what I have.
Okay.
Is that what you put too, Andy? Sorry.
It is.
And the reason I put a one sample t-test is because it is quantitative and we don't know the standard deviation. Sorry.
Yeah.
All I could see was sigma, and I couldn't even get that name out.
Okay.
Okay, question 44. Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard
Deviation. Okay. Okay, so because it's quantitative, we're only going off of the top 5 because we're not doing categorical.
Mhm.
So that takes out half of our options. We know it's not in ANOVA because there's not more than 3. We do have the standard deviation, so it's only one sample again.
Mhm.
And
we have the Z.
we have the Z-score. So it's
we
one
have the
sample.
standard deviation.
Oh, yeah, we don't have a Z-score. So again, it's a one sample t-test.
No, we have the standard deviation. So it's
Oh,
a sample Z test.
T-test.
Yeah.
Yeah. Okay.
An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation?
So again, it's quantitative.
Are you sure?
I put categorical.
I did too.
I think it's test of one proportion.
That's
Oh,
what I
yeah.
have.
Yep. You're right.
That's what I have
Yeah.
because he's
45 and the 30% throw me. Okay.
well. If it's the 30%, we know we're dealing with a proportion.
Got it. Okay.
46. A marriage counselor conducted a study of couples categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. Which hypothesis test would be most appropriate for this study?
I think the test of 2 proportion. Obviously, that's not what it is.
Well, I was debating between the
So
test of proportion or the chi-squared because they're independent of each other.
The couples, okay. Oh, so they don't rely on each other. He's just looking at the different data to see if there's a difference. So they don't rely on each other at all. So it is the chi-squared because they're completely independent of each other.
That's what I think.
Yeah.
Okay.
That's what I think. That's exactly the logic I've used also.
Yeah.
But we all know how that turns out.
Okay.
A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money clients invest in radio advertising. Which procedure would be most appropriate for addressing this question? I think it's given in the answer. Is a
Yeah.
linear regression.
I wish more questions were like that.
Me too. But these ones are actually, I feel really confident in these ones.
Yeah,
Yeah.
in these ones.
Just
these
because
ones are
they're
tricky.
so straightforward.
Mm-hmm.
I don't feel like they are on the
it's going to be
exam.
completely different.
Yeah.
Mhm.
How many attempts do we get on this, you guys?
I think 2 each, but I don't want to have to go back and redo any of them.
Hold on, I'm getting back.
I'll go ahead and submit.
I can do it.
No, I'm doing it. It just
I
sucks when there's 47 and if you get one wrong and we want to redo it.
I really think we got them all right, though.
Hold on.
You don't think so, Andy?
No, because
No.
we always get some wrong.
Yeah, we only got 43.8 out of 47.
Right.
So 46 is not right. It is not the the chi-square
So it is the 2 proportion.
proportion.
Wait. 44. Dang it.
I'm trying to find out what else we've missed. It is not 27. It is not P1 is not equal to P2. Did I do that wrong? Is that what you guys had on 27?
Let me look.
Yeah, I think that is what we had on that one.
Yeah,
So
it is not that.
Which question?
27.
A study was conducted to, so it's not P, what? A study was conducted to measure the effectiveness of a diet program that claims to help manage weight.
Let me tell you what all are wrong first before we go back and so I can
Okay.
get back in there with you.
Well, I have it all written down.
Okay. Question 16. I put yes because the p-value is greater than the level of significance. That is not right.
16.
Yeah.
Hold on.
I just want to make sure I didn't put in anything that was
I
wrong.
put no.
16, I put no because the p-value is greater than the level of significance.
Okay, so that was my error because I accidentally put yes. So we did not get 16 wrong. That was me that got it wrong. Lucky me. How in the world did we get this? Question 11, we got 0.08 out of 1 point.
Well, 11 says there may be more than one correct answer.
Okay, so we didn't get the full correct answer.
Well, what did you put?
I got approximately 95% of all 95% confidence intervals.
And we are 95% confident.
Okay, I only did one.
So it should be both of those.
Okay,
It should be,
So-
I have B and C on the paper,
okay.
but it should, I don't,
Okay, I only did one, so I got 0.08. So essentially, we only got 2 wrong because the other 2 were my errors.
so it was 42,
Let me go back.
which is a test of two proportions.
Yeah, 46.
Oh, yeah.
It's 46 in the quiz,
And then 27.
which is the test of 2 proportions, and then, yeah.
Okay.
Okay. So let me get back in there. You know what? I almost don't want to redo it again because
I'll help you. We'll get Andy off and then I'll help you walk through this. Just let's figure out 27.
well, do you one of you? Yeah, you guys figure out, and then I'll go back through and do the quiz again.
We got 42 wrong? Is that what you said?
No, it's 46 on the quiz, but on the paper it's 42.
Oh, okay.
I'm sorry. So I think we need to change it to a test of 2 proportions on 46
Okay.
and then 27 on the quiz. But you know what? That's pretty dang awesome. That's all we
Yeah.
missed.
Yeah, I'm surprised.
I'm actually very, very
So we only
impressed.
missed 2 out of the 47. The other 2 were my issues.
Sorry.
So
We'll get
what
back
do
to
we think 27 is, or how we know?
Okay, I've got a study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. Oh my gosh, you guys, I think it's B, the UD does not equal 0, because we're looking at a difference of scores. We're not looking at proportions. You were completely right on this one, Jolene.
Thank you. I'm never usually right.
I think you were right.
Okay.
What do you think, Andy?
Is it so the null would be equals 0 and alternative doesn't equal 0?
Right, but it's the
It's the
UD.
difference.
It's the mu difference. We're looking for the difference between the before and after scores.
Yeah, I think that's it.
Okay, let me say that. And
I'll submit.
are you sure?
Yeah,
Because I can.
it's okay. I'm already doing it.
I'm getting down to making sure I change that.
I got 100.
Yay!
Sweet. Okay.
Test of 2 proportions. Save that. Save
Okay,
that.
so Andy, if you want to be done, we can, and then Christina, if you want to quickly go through the answers,
Yes.
and I'll submit them.
Yeah. Can I submit this?
Yeah, if you got 'em.
I have it all written down.
Okay. But I'm scared to go off of what you have written down because the numbers are not the same.
The only thing, I mean, I'll still use this. The only thing that I don't have on here are like when it asked about the margin of error and stuff like that. But other than that, I have it all written down. But
Okay.
I'll save it off of, I mean, I'll read it, the answers to you off of.
Okay. All right. Sounds good. Thanks, you guys. Thanks, Andy. You do. Oh, PowerPoint.
Oh,
You guys okay with me submitting it as is?
Yeah.
No other
Looks-
changes?
looks great.
Okay. All right. I'll submit that today.
What? I missed one. How did I miss one? I must have changed something. 44. You're kidding me.
Did you click the wrong thing?
Yes, on number 44, here I was telling you guys it was this and blah, 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 and I put the T test instead of the Z test.
Oh, shoot.
I can't believe I did that.
Okay.
Mistake.
All right. So I will go ahead and get the PowerPoint submitted today. We will get about 94%, even if we do it perfectly.
Yeah.
And good luck, Andy. I know you're headed out of town, so good luck on your exam.
How do we do the evaluation template?
I don't know.
Have you even looked at it?
I did it already. It's done.
Too.
Oh, okay.
I've done mine. I can show you what I did.
Okay.
I just give everybody full credit. We've all worked hard through the semester. We deserve it all.
Well, that's what I said
Yeah.
too.
Yeah.
Like everybody's there. Is that all I'm supposed to turn in?
Yeah, you just turn in that evaluation thing.
And then when it says who is the main writer, so I put my name in for the design of the study, Andy for collect, Haley for the inference, and you for the PowerPoint.
Did you do yours already, Andy?
Not yet. I'm gonna.
And
I'll
then
do it.
attended the final project meetings.
That's today.
So
I'm
all of us.
So here's what I did on mine. I'm opening it up. Maybe, possibly. Open.
Okay. Well, this was
Here's
our
what
last meeting, so
I just put all of our group members at the top, and then who was the writer over here, and then it says other comments about group members. I just did a summary. I says this was probably the best group I've worked with on group projects. Each member did their steps of the process, attended all the meetings, and did everything on time. And yeah,
so nice.
well, I feel like usually when you're in a group meeting, you're always waiting on somebody or you're having to pick up the slack for somebody. And we didn't have to do that.
I didn't feel like we had to do that at all.
Yeah, we all collaborated on all portions and it was, yeah.
It was actually really nice. I'm not
Yeah.
gonna lie.
Yeah, it was.
So that's all I did. So
Awesome.
easy.
All right.
In fact, if you want me to email this to you guys and you keep just the same names and just make any different comments you want.
I already did mine.
Okay.
I just added that in, and I put who attended the last meeting. I put all of us. I put everyone.
I did too, even though I've already done it. I'm like, everybody will be there. So it's all
Sweet.
All right. Good luck, Andy.
Good luck. She's gone.
Oh, okay. All right. Okay.
I can't believe I did that.
I'm sorry. Okay, let's go through and I will do everything and then I will share with you. Okay? So you go through and give me all the answers. I will submit again, then I'll go through and give you all the answers. Okay? So we both get 100%. So when you get on number 2, are you there?
Yes, I'm here. I was just talking. Okay, so
Number 2, just tell me the answers really fast off of the quiz.
okay, so 2 is the number of people in a randomly selected classroom.
All right, 3.
3 is an observational study because the students had no control over the price.
Okay.
4 is it's impossible to determine. 5 is 2.5.
Wait, it is not
It is not possible to determine this.
5,
2.5.
2.5. Okay, 6,
146.8.
146.8. I'm saying them all back to you so I type them right. It's going to be ski right. I remember that one. Okay, 8.
2.236, which is what I have. 0.991.
0.991.
10 is the probability of a type 1 error.
Okay.
11 is approximate 95.
95%, and then we are 95% confident that the true mean.
Correct, is somewhere. Mhm.
All right. Okay.
12 is yes, the distribution of a sample mean is normal because the data is normal.
Okay.
0.019
0.019.
is
Okay.
a dependent sampling. He needs to select couples for his sample.
Okay. 15.
0.096.
0.096.
No, because the p-value was greater than the level of
Yeah,
significance.
that's the one I accidentally hit yes because, okay. All right.
17 is yes, the distribution of the mean difference of the mean difference is normal because the data has been determined to be normal.
Okay.
18 is the third one down. UD equals 0.
Okay.
19.
95% of all 95%.
Yep.
Okay.
20 is 50. 21 is no.
No, because
There's only one no here.
There's two no answers.
Oh, sorry.
40 times 0.022. Yeah.
That's the last one.
Okay.
22 is the last one.
The sample.
Yes, of the sample. Oh,
Okay.
you know what? Hold on. Sorry, I'm still broadcasting.